Okay. So we stopped reading in all these stations. Let's go a bit up again. So here are our stations that we read in. So we have for each, we have an identifier now, and we have various different informations about each station. And actually, some of the stuff, it's not so interesting. So for example, the bounds, it's something that I'm not really interested in. So it'll be cool if we could just remove some columns to clean up our data. So I want to show you how you do that. And so basically, the function that you're looking for is called dataframe.top. And dataframe.top takes in a list of column names that you want to have removed. And then you also specify the axis in which you want to remove. So if you set axis to equal to 0, then you actually start removing rows. And if you set axis to 1, then you start removing columns. And so here I'm interested in removing columns, so I set axis to 1. So let's do that. So in particular, for our stations, so the columns that we're not interested in is this bounds column and the subtitle column, just to clean up our data. So once we've done this, this is the result. You can see it's already a lot cleaner. So now we only have the ID, then the position of that station. We kept if it's in service or not, the number of logs that the station has, and then the title. It's kind of probably everything we'll need. And so, okay. So the next thing that might be useful is to extract some parts of our data frame. I've already shown you some techniques to do that with this indexing notation. I want to show you another way. There's this .log method that basically locates a subtable of your big table. And the way you use it is you call start row, end row as the first argument, and then start column, end column is the second argument. So if you have a large table, you're kind of just interested in a subset of it, you can use this log. So for example, if you're interested in the GPS positions for stations with ID, let's use 130 to 140 here. Actually, I don't think that exists, so let's do 160 to 170 here. And then we're interested in the center latitude and center longitude. This is the syntax that you would use. And so now you get these two columns for exactly the IDs that we're interested in. So then something else that is quite useful is you can, if you have a table or if you have a column, you can call mathematical functions on them. So for example, you might be interested in the minimum number. So if you take a column, let's say the number of logs column, so how many bike logs does a station have? You might be interested in what is the minimum number of bike logs for a station, what is the max, and what is the mean. And so the way this works is you extract the column of interest, and then you just call .min, .max, or .mean. So if you do that, so these are some simple statistics. So our smallest station has 6 logs, our largest station has 48 logs, and then the mean number of logs is 22.29. Okay, so something else that is quite useful is to ask questions like, what are the largest stations? Or what are the stations that have more than 30 logs? So we're trying to do some questioning with kind of if tests, right? So we want to, or in other words, we want to filter certain rows that satisfy a test. And the way you do that is you can, in the indexing notation here, you can actually use a test here. So here, so for example, here I'm checking, I'm extracting the number of logs column, and I'm testing it if it's larger than 30. And this will give me all the indices of all the stations that are large, that have more than 30 logs. And then I use this index set to actually extract the stations. So if you do that, then I can use so I save the result in a variable called large stations, and I can extract its length. So we can we can see that we have 20 large stations, and the total number of stations is 130. So maybe let's just print them out. It'll be interesting to see what are the large stations. Yeah, okay, so there's the largest ones are Vaterlandsparken and Sture Center with 42 logs, and then it kind of goes down. Interesting. Okay. Another thing so we learned how we can remove columns to clean up the data, but often it's useful to add new columns to our data. And the way you do that is you can just invent a new column name and assign data to it. So let's say for some reason we want to have a random column in our data. So I use the index notation with the column name random, and then I create random data. And so obviously here, this has to be a vector that has the same length as number of rows that I have in my data. So I use the numpy random.random method that creates a numpy array with random floats of length, and you specify the length as an argument. So here I use the length, so the number of stations that I have here as the number of arguments. So if I call this, then we have our original table plus a new random column here. Good. So now, since we have all the stations, the obvious thing is to plot them on a map. And in particular, because we have all the longitudes and latitudes of all the stations. So after a little bit of Googling, I found that there's a Python package called gmplot for Google Maps plot. Well, you could probably even use matplotlib. It's very easy with this gmplot. And so I just used the documentation to find out how it works. So basically, what you need to do is you create a new Google Map plotter. You specify the center of it and the zoom level that you want to use, and then you store that as an HTML page. So you can do that, and we can I can just open up this HTML page in an IPython notebook, and so this is what you get. So this is kind of I pick kind of the center of Oslo as the center for my map, and then I use zoom level 11 to get an overview of the map. So that should be quite good to visualize all the stations that we have. So the next thing that we need to do is we need to extract all the stations, longitude and latitude, from the data that we have. So for that, we use the indexing notation. So we can do that. So now we have a list of all the station IDs and their positions. So, but this is still in some data frame Pandas object. So we actually need to have it as a numpy array. And the way we do that is we can use, so if I'm just extracting the first 10 objects, I can use this x.values attribute to actually get the column as a numpy array. So we will use that for our plotting now. And so basically what we're doing now is we're calling this gmap.scatter plot. That's a function to kind of place items on the map. And so what we always need to provide the latitude and then the longitudes. So what I do is I extract the center.latitude column from the data frame and then get this as a numpy array using the .values function. And I do exactly the same thing for the longitudes column. And then the rest is just map-specific things. So I specify how big the markers should be and that I actually want to have markers. And then I save it as an HTML file, and I actually have to insert some API key to keep Google happy. But if I launch that, then this is what we get. So this is now our Google Maps and the HTML page that was generated, and you can see each location here represents one station. Oh dear. Where are we? Good. There's just a screenshot in case the demo doesn't work. So it's always dangerous to do live demos. Right. So now the problem is we want to merge the two tables, right? So we have a table with all the trips, and we have a table with all the stations, and the trip table uses these station IDs. And in our station table, we have a map from station ID to some kind of useful names. So it'll be kind of cool to have a big trip table that contains the information about each trip, so the start time and the end time, but also the title of the starting station, or the name of the starting station, and the name of the ending station. Right? So what we need to do is we need to learn how to merge data frames. So that's part number one. And then the second one that we would like to do is, so far we've only downloaded, or we only worked with the statistics for October, right? But it would be useful to kind of download also we've downloaded the data also for September and August, right? So it will be useful to kind of concatenate multiple data frames to get one big table. So you need to learn how to add multiple tables together to get larger tables. Let's start with the concatenating. So if we look at, so let's just quickly look at the bike stats that we had so far. The minimum start time, I'm just printing out the minimum start time and the maximum start time. And so we'll see immediately that indeed our timestamps start on the 1st of October at 4 o'clock, and they end on the 31st of October at 11 o'clock. So, so now what we want to do is we want to load in the data from September. So I've downloaded it in the same CSV format. I use the comma separator here, and I pass the dates start time and end time. So in exactly the same way I've loaded in the October data, and I stored in bike stats September. So now we have, once this is loaded, we have two tables, or two data frames. Let's wait some time. There we go. And so now we want to concatenate them. And so the way you do that is with this function pd.concat, and you just provide a list of all the data frames that you want to have concatenated. So of course, in order for this to work, all the columns must match up. Right? So you can't kind of append another table if the columns doesn't add up. But because we're loading exactly the same data, this will work for us. Okay, so that was really quick, and so now we have a new object called bikestats sep_oct. So just as a note, so this is if you use the pd.concat, you actually get a new object out with the merge thing. You can also take the existing table and append data to it. So if you want to do that, then you can use the .append method instead. Okay, but now let's look at our bikestats sep_oct. So hopefully, if you look at the minimum start time and the maximum start time, hopefully this will now range September until end of October. And so indeed it does. So now we have data from the 1st of September all the way to the end of October. So that's good. So the next thing is that we want to merge in the stations data and the bike statistics data. So just to remind you again, if you look at the bike statistics, So here we only kind of have start station, start time, end stations, and end time. And so I would like to add additional rows here that contains information about each start station and each end station. So how do we do that? The function that we're looking for is called merge. And so basically merge, as the name suggests, merges in two different data frames. Here's the syntax. So we call pd.merge. Then we have a table on the left side. So we're always talking about two tables that we want to merge. So we have a table on the left side and a table on the right side. So we need to provide a data frame object here and a data frame object here. And so then there's this thing called how. And so how actually, this is, there are different ways on how you can merge data, and I'll explain this in a second. Just be aware that there's inner. Down here are the different options. You can choose between left, right, outer, and inner. And so the default is inner. And so we need to figure out how we actually want to merge our data. And then we need to provide the index that we want to have matched up for the merge. So we need to provide a column name here that we want to have merged, and a column for the left data frame, and a column name for the right data frame. So to give you an example, so in our case, right, we have our left data frame will be the trips, and the right data frame will be the stations, and the indices or the keys that we want to match up is the start station on the left table and the station index on the right table. So these are the two columns that we want to use when we merge up. So yeah. So now there's this magical how that I still need to explain. And so for that, I think the best way is to just look at, so this is a concept that is actually from, if you're familiar with databases and with SQL. So the database people, they do this all the time. So they constantly have multiple tables, and they want to merge in, they want to create one larger table out of it. And so this is just a web page that on databases in general, but it explains this different types of merging. So basically, so imagine, so let's look at okay, so this is the initial table that they're working with. So they have a table here on the left-hand side. It contains pirate, monkey, ninja, and spaghetti, and a table on the right-hand side. It contains these four values. And so basically now the goal is to merge these two tables in such a way that always the name on the left table matches up with the name on the right table. So ideally you want to have kind of pirate and pirate together and ninja together here. But the problem is, and this is also a problem that we have, is that sometimes there is no match from the left table to the right table. So pirate shows up on both tables, but monkey, for example, doesn't show up on the right table. In the same way, rutabaga doesn't show up on the left table. So, and this how attribute basically describes what should be done with these rows where you don't have an associated key on the other table. So let's look at what, if you choose inner, if you set how equals inner, basically what we're getting is we're getting only the rows where we have a match on both the left and the right table. So in other words, we only end up with two rows. So the merge table now only contains two rows, namely one where we have pirate and pirate on both sides and ninja on both sides. Right? So this is kind of the inner part, because we have the intersection of both tables, what we get back. The opposite of that is outer. So in outer, you get the full left table and the full right table. And in case there is a matching key, then you get just pirate and pirate on both sides. But in case if there's no matching key on one side, you just get nulls or nones. right? So here monkey showed up in the left table but didn't show up in the right table, so here this was just replaced by nulls. And the same with the spaghetti, and then we also have some nulls on the left-hand side because we have these two indices that didn't show up on the left table. So in other words, this is kind of the union between the two tables. Every key that was on the left table will also show up on the merge table, and also every single key that showed up on the right table will also show up on the key. And so now this idea just follows. So now if you set how equals left, then what you get is you get every single key for your left table, and in case the key doesn't show up on the right table, it will just be replaced by null, but not the other way around. So the keys that are only in the right table but not in the left table, they will not be part of the merged list. Okay? And the same thing, well, then there's various different variations, but that's not so important. Does that make sense? So let's look at the case that we want. So we have, let's look at the column names that we have. So let's say our left column are the bike statistics, and our right column is the stations. And so the columns that we want to merge up for now, let's say, is the start station on the left column, and actually for the right column, it's going to be the index. So it's not listed in here, but it's the index that you want to use. Okay, and so which type of merge do you think we want to use? Which how flag do we want to use? Do we want to use inner, left, or right, or outer? Any ideas? So I suggest that we use left, because basically we want to make sure that we still list all the trips. We want to make sure that we list all the trips, but in case the trip uses a station ID that is not part of the stations table, then we just fill out this information with nones, or with just empty values. So this will just be a trip where we don't have more information about the station, and then we need to handle it otherwise. But if we used inner, then we might lose some trips on the way, because these trips that where we don't have information on the stations, they will just be removed from our list, right? So that's probably not what we want. So for that reason, I came up with this command here. So I use pd.merge. Then our left table is bikestat_sept_oct, so the September-October statistics. Then the stations on the right-hand side. And I set how equals left to indicate that I want to do a left merge. And the column that I want to, the column that I want to merge on is the start station for the left table, and the index, for the right station, because the stations table contains the station IDs as part of, we set it as the index. Okay, so if I execute this command, then it looks quite promising. It looks very promising. So what do we have? We have the start station, the start time, end station, end time. So this is our original left table. But now we have additional columns here. And these additional columns are exactly the columns that from the stations table filled out for that specific station 291. So basically, all these columns here are now the information about the station 291. And so now this is getting a lot more useful, right? So you can actually, for example, if I look at the last trip here, this trip started at 268, and now I can actually go all the way to the right, and I can see, okay, so this trip actually started at Stensparken. Okay, so let's just double check that we haven't lost any trips by doing this merge. So I just print out how many merged, what is the length of the merged table, and what is the length of the original table. And so indeed we get the same number, so everything is still good. So now we obviously want to do the same thing for the end station. And remember, so here it's actually important now that we use left, because remember for the start station, we didn't, well, at least I think all the start stations are actually valid identifiers. But for the end station, we actually had nan values. There's some values that are just not filled out, right? And so I don't want to lose them. And so here, it is actually important that I set how equals left, because otherwise these strips would just be removed from my data set. So now I'm basically, what I'm doing now is I do another merge for now the end stations. So I again I have the merged bike stats on the left side, the stations on the right side. I do a left merge. I use the end station as the merge key for the left table. And I again use the index for the right table. And so the only thing that I do now is I have this additional flag here, suffixes. And that will so the problem is now I will have duplicate column names, because I have the columns for the stations twice. And so the suffixes will just add a suffix to all these columns so that I can separate them. So for the start stations, they will all have a suffix underscore start, and for the end stations, they will all have a suffix underscore end. So let's merge that. And so now this is our, let's just get the head. OK, so this is now the fully merged table that we get. And so you can see the column names here now indeed start with underscore start. So this is the latitude center for the starting station, and the longitude center for the starting station, and so on. So now we can look, let's see, so this first trip went from Hanshaugen Park Noor to Professor Aschehoeks Plus. Yeah. Good. So that's quite useful. OK, any questions regarding merging? No. So to finish up, I just want to show you some more use cases or some more questions that we could ask. So for example, what are the busiest stations? And so the way we've actually seen this already. So the way we do this is but now we can actually operate on the merged bike statistics, so that we also get the station names. So what I do is I extract the start station column, and I use this value counts method. So again, remember the value counts counts up how often does each value occur in that table. And so with that, I just need to extract, let's say, the 5 top appearances of that, and print them out. And so this is just the index set now. So now so far we only get the index of the station, and then how often that station occurred. So all we know now is that station 233 was used almost 20,000 times. And then 267 was used 17,000 times. But now if I'm interested in actually getting the station's information, what I can do is I can get the index column here for that result, and use this as an index for the stations table. So if I do that, so now I can actually get information about the station information about these busy places. So you can see this Alexander Schellensplatz. So this was used almost 20,000 times. This is the most busy station in Oslo. And then Bislett Stadion and so on. So now it might also be useful to kind of to do some more comparison. So, for example, so what are we doing here? So here, we're indexing, we're getting the most busy station. So the busy station, so this, remember, the busy station was the list of the busiest stations. I get the index of that and extract the first index. So now I have the identifier of the busiest station in Oslo. And now I use this to make a test for the merged bike stats start station. So basically, what this test in here will do, it will give me the indices of all the trips that started at that busiest station. Okay? So I get a little list of trip indices that started at that busiest station, and then I get the full. So far I only have the index set, and so by using it as in the index itself, I get the full information or the full table of that. So let's look at this. So here we go. So here are all the trips, and so the first thing is we can check that indeed they all these trips start at Alexander Schillen's Plus. So if I go down, it's always the same starting point. And so now we can, for example, plot it, and we get actually. So here now we get a lot of plots. So I'm not sure how meaningful this plot is, because here I'm actually plotting all the columns, so including kind of the random value, which is somewhere down here. But so what can we see? The start station, because I fixed it, so this is now a constant value. The end station, here we can see where these strips always ended up, just where is and these indices, and then we have the latitude and longitude. I mean, they are not really constant, but they're so small compared to these values up here that we don't really see the variation. Okay. So another question that we could ask is, what is the usage of the city bikes for each weekday? So maybe you want to understand, is it more the commuters that are using the bikes during the week, or is it maybe more the just enjoying using bikes on the weekend? So how do we do that? So remember when we have, so let's for start, let's look at what this A key plus stats is. So again, so this A key plus stats is just the statistics of the Alexander Schillen's Plus. So these are all the trips that started at that particular station. So let's try and find out how many people use that station for every single weekday. So how many use it on Monday, Tuesday, Wednesday, and so on. So if we look at the index of this table, we can see that the index is, we set the index is a bunch of dates here. Okay, so we set the index to be the dates. So we have the starting point, the starting time for each trip here as the index. Now the trick that we can do is so these are all of object date times, but we can also call the .day attribute on it. And what that will give us, it will return us the day of that date in the month. So the first trips here were all on day 1 of the month, and the final, so there's a lot of dots, and the final trips were all on day 31 of that month. So, but that's not quite what we want yet. Instead, we want to have the weekday, and conveniently, there's a function called weekday, and this will now give us the index, but the index names, but now each integer here represents the day of the week. Right? 0 is going to be Monday, and 6 is Sunday. So here we can now see on which weekday these trips occurred, each trip occurred. And so now what we do is, so here I just create a copy because we want to, of the data, because I'm going to change the data now, but this is not so important. But so what I'm doing now is I create a new column in my data with the column name weekday, and I set it equal to the statistics, the data frame .index.weekday. Okay? So I'm expanding my data. And so now, if you look at the result, we can see, indeed, we have a new column, and that column represents the weekday when the trip started. So that's good. Then I also created a new column called counter. So I will use later on when I add up. I want to show you how you can add up the values of columns. So I just use a counter and set it constant to 1 because I'm interested in the number of trips. And then I just extract the two columns that I'm actually interested in, namely the weekday and the counter. That's all I need. So then this is the resulting table that I have now. So for each trip, I have the starting time still. This is my index. Then I have the weekday, and I just have a counter, which is just a helping column for me. And so now, what I can do is I can use this. I can use this group by function. So and the aggregate function. And so what that will do now, so this is actually equivalent to using this value counts. But another way of using, so basically what I'm interested in, right, I want to understand how often does each weekday here occur. How often does 1 occur, how often does 2 occur, and so on. So the obvious thing would be to use value counts. There's a little bit more flexible method, is using this group by and the aggregate function down here, which basically does exactly the same thing. So what it's saying is that I want to group by the weekday column. So I want to kind of merge all together all the same values in the weekday column. And when I squeeze them together, what I want to do is I want to sum up all the values. And so what I get then is I get a new data column where the weekday has disappeared because I grouped by it. So the weekday has disappeared into the index, and the counter now tells me how often each weekday has occurred. So the new table now tells me on Monday the station was used 3,000 times, on Tuesday 2,800 times, and so on. And so what is not so pretty yet is that I have these values here, just integers representing the weekdays. So it would be nice to kind of have the actual names of the days. And the way I do that is I just update the index. I set the index from these integers to the list of the actual weekday names. So if I do that, then this is my final table that I get out. And I can now plot it, for example, with a bar plot. And here we go. So now we can say for that specific station, this is the distribution of usage over the days. And Saturday and Sunday is here at the end. Right? You can see the usage is fairly kind of high during the week, a little bit higher on Thursday for some reason. Is that maybe a party day in Oslo? Maybe. So it'll be interesting now to see on which time over the day the bike stations are being used, right? Maybe there's kind of a peak at midnight or so. And then it kind of tops off. Okay, and that's exactly the last thing that I wanted to show you. So maybe rather than finding out the weekday, it'll be cool to find out how the distribution is between the different hours. And the way I do that is exactly the same. So I create a new column called hour, and I set its value to be the index, remember, was the date, and so the hour of each date. So I think this is just a warning. So I should probably, yeah. And so now if you look at the results, our new table contains the weekday, the counter, and indeed the hour in which it started. So remember so you can actually see it here. So this is hour 4, and there's the equivalent integer here. So this is in GMT time. That's why it starts at 4. And then I can use the same trick here with the group by and aggregate to sum everything up. And I get the distributions, the usage distribution for all the different hours of the day. So starting at 4, you can see the numbers clearly go up here between 6 and 7. Then it seems to be going down again, all the way up to 22 when the station closes. And then I can plot that. And yeah, so here we go. Here's our usage distribution. So clearly these seems to be commuters, right? Getting up at 6, this is not just something that you do on a weekend. And then people stop working at around 2 or 4. So they slowly start going home. And there isn't so much activity actually at night. So maybe it's not the party people, but more the workers who use it. Okay, yeah.
Would it make sense to adjust the time so that it will be the time of Greenwich? Because I think it's like 4 o'clock. That's the time at Greenwich.
Yeah. So I'm sorry. So here you always have to add 2 hours. So really in Oslo time, this is 14 o'clock. So really it's actually 16 o'clock in Oslo time. Yeah. So yeah, it would make sense to kind of just add. I think, is that what you're asking?
Yeah.
So I think you should be able to tell Pandas in which time zone you are, and then it will do the correct.
Tables now, it's the time in Greenwich.
Yeah. Yeah. So I haven't checked that, but I'm pretty certain that you can specify the format of the dates that you want to have printed out. Okay. Are there any other questions regarding Pandas? No? Okay, then see you next week.